Good morning students, my name is Radha and I will be teaching formal languages and automata theory in the 5th semester. So in this we will cover an introduction to finite automata, explore the types of finite automata and learn about the design of finite automata. Here the first unit consists of introduction about the finite automata, formal definition of finite automata, types of finite automata and how to design the finite automata. Next one is the formal definition of finite automata. Finite automata is a mathematical model of a system with discrete inputs and outputs. That means it is a mathematical model of a digital computer which can be used to recognizing the patterns. The finite automata can be classified into three types. One is deterministic finite automata, second one is non-deterministic finite automata, third one is non-deterministic finite automata with epsilon transition. Deterministic finite automata means it's simply called as a DFA. DFA has the finite set of states and finite set of input symbols. The main thing in the deterministic finite automata, it has only one transition is possible from one state to another state on one input symbol. Non-deterministic finite automata also have the finite set of states and finite set of input symbols, but the difference between the deterministic finite automata and non-deterministic finite automata is more than one transition is possible for the same input symbol in the non-deterministic finite automata, simply called as a NFA. But in the deterministic finite automata, only a single transition is possible for single input from one state to another state. Last one is a non-deterministic finite automata with epsilon transition. In this, we are using null string also input symbol. This is a finite automata machine. The finite automata machine consists of input tape, reading head and finite control. Here the input tape is divided into number of cells. Each cell stores one input symbol. Next one is reading head. Reading head which is used to read input symbol from the input tape. And next one is a finite control. Finite control point to the current state and it decides to move on next state on receiving the input from the input tape. Read head reading input symbol from left to right. This is a finite control, reading head. This is an overview of the finite automata machine. The finite automata consists of three things. One is input tape, second one is reading head, third one is a finite control. Here the input tape is divided into number of cells. Each cell store one input symbol. Read head which is used to read the input symbol from the input tape from left to right. Finite control point to the current state and decide the next state based on the input symbol received from the input tape. Next one is formal definition of deterministic finite automata. Already I said deterministic finite automata consists of finite set of states and finite set of input symbols, but the only one main condition is only the single transition is possible for single input symbol from one state to another state. Here the finite automata can be represented using the symbol as a m, that means m equal to q comma summation comma q naught comma f comma del. Here the finite automata consists of 5 tuples. First tuple as a q. Q represent the finite set of states. Summation represent the finite set of input symbols. Q naught is a starting state of the finite automata. Here the starting state can be represented by using arrow mark. Here Q0 belongs to the finite set of state Q. Next one is F, that is a final state or accepting state. Here the final state or accepting state is a subset of the finite set of state. That means the deterministic finite automata have more than one accepting state. Next one is a transition function. It can be represented by using the tuple till. The transition function is a process of moving from one state to another state for one input symbol. Next one is a transition table and transition diagram. Here the transition table or state table is a tabular representation of the transition function. It has two arguments, one is state and another one is a input. Here in the state we are representing the starting state by using arrow mark and final state by using the star in the transition table. Next one is a transition diagram or state diagram. The transition diagram is a pictorial representation of transition function which consists of set of states, finite set of input symbols and a finite set of transitions. Next one is a example for deterministic finite automata. In this diagram have two states, one is A and another one is B. That is a Q equal to A comma B. Here Q is starting state and B is a final state. Here A is represented using one arrow mark that represents A as a starting state. Here B represented by using double circle. The double circle representing that state as a final state. Next one is finite set of input symbols. In this diagram we are using two input symbols, that is a summation equal to 0, 1. Next one is transition function represented by using del. Initially we are applying transition function for the starting state A, 0 and A, 1. First del of A, 0, we are applying the transition function on the state A on input symbol 0, then it goes to the next state B. So del of A, 0 equal to B. Next we are applying the input symbol 1 on the state A, then it goes to the same state. Del of A, 1 equal to A. Next we are applying transition function to the state B, del of B, 0 equal to B, del of B, 1 equal to A. Because if you are applying a transition function for the input symbol 0 on the state B, again it reaches the same state. So del of B, 0 equal to B. Then we are applying transition function on the input symbol 1. Then it goes to the next state, that is A. So del of B, 1 equal to A. Here the starting state is A and accepting state is B. Here B is represented by using double circle. Next one is transition table. Transition table consists of states and input symbol. Here we are using two states, one is A and another one is B. The A is a starting state, it represented by using arrow, and B is a final state, it represented by using star. Here we are using two input symbols 0 and 1. We are applying transition function on the input symbol 0 on A, that is a del of A, 0 equal to B, del of A, 1 equal to A. Then next del of B, 0 equal to B, del of B comma 1 equal to A. Next one is a design of DFA. For example, design a DFA for the language accepting set of strings that ends with AB over A comma B. Here first we have to generate the list of all possible strings of the language. Here the input symbol is A and B. Then the language starts with either A or B, but it should end with AB. So initially we are starting the string A and then end with AB. So first string as AB. Then starts with A and end with AB. So AAB. Then third string is starts with B and end with AB. So BAB. Like that we have to generate all possible strings of the language. Here we have to remember one important thing. Number of states required to draw the DFA diagram is length of the smallest string in the language plus 1. So in this example, smallest string in the language is AB. Then number of states required for this problem is smallest string in the language plus 1. So AB plus 1. So AB plus 1, length of AB plus 1 equal to 2 plus 1 equal to 3. So we need 3 states to draw this diagram. Initially we are drawn the 3 states named as a Q0, Q1 and Q2. Here Q2 is a final state and Q0 is a starting state. Q0 is represented by using arrow mark, then it is called as a starting state, and Q2 is represented by using double circle, so it is called as a final state. Next, we have to take the first string. So first string is AB. So in this first input is A. Now we are applying transition function and the input symbol A on state Q0. So Q0 comma A Q0 comma A equal to Q1. Next we are processing next input symbol Q1 comma B equal to Q2. So first draw the DFA diagram for given condition. So here the given condition is accepting set of strings that ends with AB. Now the condition is satisfied. We are processing the first string AB, then it reaches the accepting state and also end with AB. Next, the string maybe starts with B, then we have to apply another one transition in the state Q0, the Q0 comma B equal to Q0. Then the string starts with B and followed by 2A. So again we have to apply another one transition on the Q1 state, Q1 comma A equal to Q1. Then we have to consider the Q2 state, that is the accepting state. Here also we are applying two transition function, one for A and one for B. Now we are applying transition on the input symbol A, then Q2 comma A equal to Q1, because our condition is set of strings that ends with AB. If we are applying Q2 comma A to Q1, then finally it reaches the accepting state with the condition AB. The same Q2 comma B to Q0. So like this we have to draw the DFA diagram. Here we should remember two things. First, number of states required to draw the DFA, that is a length of a smallest string plus 1. So in this example, smallest string is AB, length of AB is 2, 2 plus 1 equal to 3. So we have to draw the 3 states in initially. After that, we read the given condition. Design a DFA for the language accepting set of strings that ends with AB over A comma B. So all the strings must end with AB. So first draw the DFA for the given condition. For that, Q0 comma A equal to Q1 and Q1 comma B equal to Q2. Now we have to check any one string. For example, BAAB. So BAAB, first string is B. So we have to process the string B. Q0 comma B equal to Q0. Then read the next input symbol. Q0 comma A equal to Q1. Now the finite control is in Q1 state. Again now read the next input symbol A. Q1 comma A equal to Q1. The last string is B. Q1 comma B equal to Q2. It reaches the accepting state. That's all in this video. So we see what is meant by finite automata, types of finite automata, what are the components of finite automata, and how to design the finite automata. These things are discussed in this video. This is your reference book. Thank you.